Okay, so today we're going to talk about synthesis reactions. Okay, better if you could see that, but there you go. So synthesis reactions. Okay, so a synthesis reaction is the basic chemical reaction that you can have. There are the basic types, and then there are more the advanced types. So we're going to talk about both. So first we're going to talk about the basic type. Okay, so it's when you have two elements, okay, A plus B, and they're going to combine to form AB. Now, they'll combine this way if A is a metal and B is a nonmetal. Okay? If it's the opposite way around, if A is a nonmetal and B is a metal, then you're going to get Ba. All right? So it all depends upon what these things are. Okay? Because you always have to have it set up where when you create this one compound, and for what we're going to do, this compound will always be ionic. Okay, it's got to have the cation first, and then the anion. Okay, one of the ways you can recognize it as a synthesis reaction is there's always this little plus between just two elements. All right, by now you should be able to tell the difference between an element and a compound. Compounds tend to end in IDE or ATE or ITE. So if it's just an element name and you see this little plus, that's saying that you have a synthesis reaction. All right, we're going to go over some basic types, and then we'll talk about the more complex types for where you would see this in honors chemistry. Okay, but you would see the basic type in both honors and college prep. So let's talk about how to predict a synthesis reaction. So you're going to see elements listed. So something like sodium plus nitrogen. Okay, so predict the reaction. All right, not only you have to predict the reaction, you have to also balance it and tell me the states and the oxidation numbers. If you're not sure about oxidation numbers, I will explain some simple rules about oxidation numbers in this video, but if you're unsure about oxidation numbers, go to my oxidation video and you might want to watch that first. Okay, so how do we start the problem like this? So we write down the elements, sodium and nitrogen. Okay, now we have to check if these are monoatomic, diatomic, or tetraatomic, or octatomic. Now remember, some elements can't exist by themselves. The chlorine and bromine should be switched, but that's okay. So they form a 7 on the periodic table. All right. So these 7 elements, and again hydrogen will be up another row, cannot be by themselves. In the armpit of this 7, again, this is how it looks on a periodic table, except chlorine's up here and bromine's down here. You have sulfur. Now, sulfur tends to want to be octatomic. It can be monatomic by itself, but for the most part, it tends to be octatomic. And phosphorus is tetraatomic. So every other element then will be monoatomic. So sodium is not a part of this list here. So I would expect sodium to be monoatomic, but nitrogen is. So nitrogen is a diatomic atom. All right, that means you always have two of them. So we put a little arrow sign. So we have to go look at, well, what is the metal and what's the non-metal? Well, sodium is our metal. All right, and the metal will form your cation. Nitrogen is your non-metal. And it'll form the anion. So when I write these together, I have to write the metal first. Sodium and then nitrogen. Now, here I have an ionic compound. So I have to check the charges. And anytime you write an ionic compound, you have to check the charges. All right, not only do you have to check them, you have to crisscross them. All right, so, and if you want to do it maybe on the side, some of you are a little bit more advanced, you don't have to do that, but sodium gets a +1 charge when it's in a compound. Okay, and nitrogen, well, that gets a -3 charge in a compound. So when I crisscross them, all right, I need to put a 3 behind that sodium to balance the charge. Okay, and that is the one and only formula for sodium nitride. Okay, now sodium is a metal, so it's a solid. Nitrogen is a gas. You're breathing it right now, and this will make a solid always. All right, so it's always a solid all the time, no matter what. Now we do have to go and balance these things. So you might put a 3 there for the sodium, but then you realize you have to put a 2 in front of here to balance that nitrogen. Okay, and that would give you 6 sodiums. All right, so now we have a fully balanced equation with the states. Now, as far as oxidation numbers are concerned, it's really simple. An element that's not connected to anything else, all right, whether it's diatomic, monatomic, has an oxidation number of 0. So sodium has an oxidation number of 0, and nitrogen. Again, oxidation numbers are something that we've come up with to track the flow of electrons in a chemical reaction. Now, sodium, since the charge is 1+, will have an oxidation number of +1. Nitrogen, since it has a charge of 3-, it has a charge of -3. So, for a monoatomic ion, the charge equals the oxidation number. Okay? So, if we said that sodium is going from 0 to a +1, and nitrogen is going from a 0 to a -3, well, what does that mean? Okay, so again, the convention, oil rig. Okay, so what's oil rig mean? So oxidation is loss of electrons. Okay, reduction is gain of electrons. Okay, so if we look, again, electrons are these negative things. So if you lose electrons, you become positive. So sodium is going from a 0 to a +1. So it is losing electrons, and therefore that is your oxidation. Nitrogen, okay, goes from a 0 to a -3. So it's gaining electrons, and that is your reduction. All right, and that's synthesis in a nutshell. All right, we'll go try a couple more to see if you can do this. So let's try this example. So phosphorus plus zinc. So hit pause and see if you can do this. All right, hopefully you come back. So we write phosphorus down and we write zinc, the two elements. Again, recognizing that it is a synthesis reaction by, there's a little plus sign in between two elements. There's no IDE in here. There's no ATE or ITE. All right. So again, we have to go check whether these are diatomic or octatomic or monatomic. Well, if you look at your list, phosphorus is P4. All right. Zinc is monoatomic. Now, which one's the metal? Well, zinc's the metal. All right. And that means nonmetal. Phosphorus is your nonmetal. So zinc has to go first. The charge of zinc is 2+, and phosphorus is 3-. So the formula is Zn3. Oops, put N. Zn3P2. Okay, I was thinking about nitrogen for some reason. The last example. So, all right. So again, rewriting this down here, cleaning it up. You might want to go and balance it. So this is a little bit tricky one to balance. Not too bad. You got 4 phosphorus and 2 there, so we put a 2 there, and that gives us 6 zinc. So right, we come up with something like this, and everything should be solid across the board. As far as the oxidation numbers, again, phosphorus and zinc, okay, they have an oxidation number of 0 to begin with. And again, since zinc has a charge of 2+, that means zinc is going to a +2. Since phosphorus has a charge of 3-, it's going to a -3. So again, here you are gaining electrons, here you are losing electrons. So this is your reduction, and over here is your oxidation. Okay? Oops, I should have shown that before. I didn't realize I was out of frame. So again, to reiterate that, phosphorus goes from a 0 to a 3-, zinc goes from a 0 to a 2+. Okay? And that's pretty much it for college prep chemistry. And honors chemistry takes it a little step further. So if you're in honors, you're going to have to keep watching this for a few more minutes. So in honors, we have another type of reaction, that's synthesis, that is a little bit more complex. It's when you have a metal oxide that is ionic, so it follows ionic rules, and a non-metal oxide, which is covalent, and it follows covalent rules. Okay, so what you're going to get is an ionic compound that has a polyatomic ion in it. Now, this polyatomic ion will have the same stem as the non-metal oxide. So here's what I mean by that. So let's say we have calcium oxide, okay? And we have sulfur trioxide. So again, you got covalent naming system, so you're going to see dis and tris here. So sulfur trioxide is SO3. All right. So anyway, So what do I mean by the stem? The stem here of the nonmetal oxide is sulfur. So there's only two polyatomic ions that I've given you that has sulfur in it. So it's either going to be sulfur or sulfate. So how do I know? Well, which one to choose? Well, the polyatomic ion is going to have the same oxidation number as the stem. All right, so I'll show you what that means. So you have to go back and figure out, well, what is the oxidation number of the stem? So again, this is a neutral compound, so it's going to equal 0. Okay, the oxidation number of oxygen is -2, and there are 3 of them. Sulfur we call that X. Okay, so let me expand this out a little bit. Okay, and that sulfur will have a +6 oxidation number. Okay, so you want your polyatomic ion to have a +6 oxidation number. So if you look at sulfite, okay, well, sulfite, again, if you want to figure out the oxidation number, since it's a polyatomic ion, it equals -2. And again, 3 times -2 would be a -6. Sulfur would be 1x. So again, moving some stuff around, sulfur would have a oxidation number of +4. So it's not sulfite. So it's not that. Because they have to have the same oxidation numbers. Well, what if it's SO4 2-? Okay, well, again, each oxygen is a -2 charge, so that's a -8, and it has to equal -2, and we'll call it X. Well, the only thing to satisfy this equation, if that sulfur is +6. Okay, so that tells me which one to choose. So it would be calcium sulfate. And just like over here, calcium has a 2+ charge, oxygen is a -2, that's why it's CaO. Again, there's covalent, there's no charge. And over here we got calcium with a 2+ charge and sulfate with a -2, so it's 2 to 2. And so we don't need to write anything, okay? You have 1 calcium here, 1 calcium here, 4 oxygen here, and 4 there. This will always be a solid. This will always be a gas. And this will always be a solid. All right? So I'm going to give you another example to do before we call it a day. So let's say we have sodium oxide. Okay? And again, sodium and oxygen, all right, that's the formula they make. Let's say it's dichloro pentoxide. Well, the stem here is chlorine. So there are 4 possibilities. ClO4, which is chlorate, ClO3, which is, this is perchlorate, this is chlorate, this is chlorite, and this is hypochlorite. So it's going to be one of those 4. So you got to figure out what the oxidation number is on that chlorine, and then go and compare it to these 4. Okay, so hit pause and try that on your own. Well, hopefully you're back. So if you look, if we want to look at this oxidation number right here, all right, again, this is going to equal 0 because it's a neutral compound. Oxygen is a -2, so that's a -10, okay, equals 0. and we'll call chlorine 2x. So that has to be plus 5. Well, which one of these is plus 5? Now you can go randomly, or if you picked out chlorate, you will see that chlorate has a plus 5 oxidation number, because you would need a plus 5 to make this true. So this means that this formula is going to be sodium chlorate. Again, sodium, check the charges, ClO3 minus, this being a solid, that being a gas, and this being a solid. The only thing is you're going to have to go and just balance it a little bit. So we have 2 sodiums there. So I need to put a 2. That also gives me 2 chlorines. It gives me a grand total of 6. 3 times 2 is 6 oxygens. And over here, 1 plus 5 is 6. So that's all you had to do. So this is an example of, again, a metal oxide and a non-metal oxide. Okay? And that is synthesis.